This video is on ratio and proportion from our ratio, proportion, and percent module. So let's look at some definitions first and kind of fill in here. A ratio is just the quotient, meaning division, the quotient of two quantities, and it can be written in one of three ways. 1 to 2, like this, where you actually write the word 2 and it's read 1, 2, 2. That's kind of old-fashioned. Or as a fraction, but read 1 to 2, or this way with a colon, 1 to 2. This is the predominant way that we will be using. Ratios should be written with the same units for each part. When you have ratios whose units are different, that is called a rate. So a rate is a comparison with different units, like miles per gallon. We're comparing miles to gallons. That's a rate. A proportion is just a mathematical statement that two ratios are equal. So it's when you set two ratios equal to each other. So let's look at some examples here. The first one says write a ratio or rate for each phrase. Use fractional notation. So we're going to use this notation. The ratio of 60 days of sun to 20 days of rain. And the order matters. It has to be in the order given. So 60 to 20. Now, like fractions, ratios have to be simplified. So let's first divide by 10. That gives us 6 to 2. And then let's divide by the LCD, or excuse me, the GCF here, which is 2. And that gives us 3 to 1. Now, if that was just a fraction, we would just leave that as 3. But because it's a ratio, we like to show that 1 in the denominator. The ratio of 2 parts salt to 5 parts water. I know this seems like two different units, but it's not. It's both parts to parts. So it's just 2 to 5. This one is tricky, so pay attention. It's a ratio of 18 inches to 2 feet. Now we can't write 18 to 2 because that makes it look like the 18 inches is bigger. So if your units are measurement units and they don't match, you have to make them match. And the easiest way to make them match is to convert the bigger one to the smaller one. So if 1 foot is equal to 12 inches, then 2 feet is equal to 24 inches. So we cross that off. We don't want 2 feet, we want 24 inches. And I'm going to use a darker marker here because I'm thinking this one is not showing perhaps on your screens quite as well. So I changed 2 feet to 24 inches. Now I'm comparing inches to inches. Let's kind of move this over here for space. So now I have 18 inches to 24 inches. So I have like units, and I have to now simplify this by dividing by the greatest common factor, which is 6, and I end up with 3 to 4. So what you end up with perhaps may not look like the numbers that you started with. So be very, very careful on ones that are measurement. Units have to match. Another odd thing that can come up, and this doesn't happen too often, but it does, you can have ratios of decimals. So this is going to be 2.5 to 3.15, but you can't leave decimals inside of a fraction. And so what has to be done here is we have to move those decimal points by multiplying by a power of 10. So in order to get the decimal points gone, I need to move my denominator 2 places, or multiply by 100 to make it 315. So I have to move my numerator the same number of places. So 1, 2, fill in with a 0. Now I have to simplify that, and I have no clue what goes into 250 and 315 as the GCF, but I do know that it's divisible by 5. So I'm going to start there by dividing by 5. 5 goes into 250 50 times. 5 goes into 315. If you do the long division, you get 63, and we got lucky because that actually is in lowest terms. So 5 was the GCF in that case. So don't leave decimals inside of ratios or fractions. Example 3 says, given the rectangle shown, find the ratio of, now it has to be in this order, width to length. So what you want to do is write yourself a little guide, width to length, and we're going to put our width and length in that same order. So the width here is 5 feet, the length is 7, and I have my ratio. Okay? The second part of this says, then find the ratio of length to perimeter. Length to perimeter. Again, write yourself a guide. Well, I know the length, but I don't know the perimeter. However, I do have a way to find the perimeter. I can just label all my sides and add them up. So the perimeter, if we can either add them up, which is probably the easiest thing here, or you can say 2 lengths plus 2 widths. Doesn't really matter. So the perimeter is 2 of the 7s and 2 of the 5s. So our perimeter is 24. So the ratio of length to perimeter is 7 is my length, perimeter is 24. So before I could write my ratio, I had to do some calculation and figure out that my perimeter was 24. All right, let's look now at proportions and how we solve proportions. We solve proportions like we solve equations. And it's true that we have, with a proportion, if A over B is a ratio, is equal to C over D, then it is true that their cross products are equal. So A times D is equal to B times C. Let me give you a quick example. You know that 1/2 is the same as 4/8. You know that. Those are equivalent fractions. It's also a proportion. It's 2 ratios set equal to each other. The cross products are equal. 1 times 8 is the same thing as 2 times 4. That's a true statement. So we use that idea to solve a proportion like we solve an equation. So we're going to use the rule of cross products to solve this. What we're saying is 45 is to x as 5 is to 7. So we're going to use our rule of cross products. So 5 times x is equal to 7 times 45. And I know it is because I said those 2 ratios were equal. Or 5x is equal to 315. Divide both sides by 5, and I get x equals 63. And I actually solved for x in that proportion. So let's try another one of those using the rule of cross products to solve a proportion. On the next page, I have x minus 5 over 3 equals x plus 2 over 5. We're going to use the rule of cross products, but here we have to be careful because our unit in the numerators has something added or subtracted. So I'm going to put that in parentheses, and you're going to see why. Rule of cross products says 3 times x plus 2. So if I didn't have that parentheses there, you wouldn't know it was the distributive property. Equals 5 times x minus 5. Now I'm going to solve it like a regular equation. So distribute 3x plus 6 equals 5x minus 25. I distribute it. Get variables on one side and numbers on the other since there's no like terms to combine. 6 equals 2x minus 25. Let's move up here. 6 equals 2x minus 25. My variables are on the right, so I'm going to get my numbers on the left. So 31 equals 2x. Divide by 2, and oh my gosh, yes, I realize it does not go evenly. It's okay. So you can leave it as an improper fraction, 31/2, or you can actually do the division and write the leftovers as a mixed number. So again, we're using that rule of cross products. We're going to do the same thing here, but before we can start, I need to rewrite this as a improper fraction. So that is 11/5 over 6 equals x over 10. So still cross products. So 6 times x equals 11/5 times 10. Let's put that over 1. We know how to multiply fractions. I can cross cancel, and I end up with 6 times x equals 11 times 2, or equals 22. I divide by 6, and I get x equals 22/6. Let's simplify that, but leave it as an improper, and I get 11/3 is equal to x. 3 2/3 if you wanted to change it. So I first changed this to an improper, and then again, rule of cross products. It's one of the handiest rules in algebra you will learn as you go along. All right, let's look at some problem solving. Example 7, it says on a Chamber of Commerce map of Abita Springs, 5 miles corresponds to 2 inches. How many miles correspond to 7 inches? So on one of these, what you want to do is you want to set yourself up a guide of what you're comparing. We are comparing miles to inches. So the miles on top, inches on bottom. That's what I chose. So the first one will be given to you. 5 miles corresponds to 2 inches. Then for the right side of your proportion, you're going to be given one more number. 7 inches. Where do I put that? Well, I go back to my guide and it says inches are in the denominator, so I put it here. We'll use m for miles, that's what's missing. And I have my proportion. Cross products, 2 times m equals 7 times 5. I divide by 2, and I get the miles is 35 halves, but because of the context of the problem, we definitely want to show this one as a mixed number, which is 17 1/2, or if you prefer the decimal, which I don't, if you've had me for more than 5 minutes, you know that, 17.5. So either 17 1/2 equals m or 17.5, but we used a guide and set up a proportion. Let's do another one. Convert 7 feet to yards. So what are we comparing? So for our guide, we have feet to yards, feet on top. On this one, what you're going to do is use a conversion that you get off of your conversion table, or you probably know this one. Feet to yards. 3 feet makes 1 yard. So that's the left side of my proportion. Now we're going to fill in the other number that we're told. We're told 7 feet. So where does that 7 go? It goes in the top because of my guide. 7 over, I don't know the yards, we'll call that y. Cross products, 1 times 7 equals 3 times y. Divide by 3. And I get y equals 7/3, which is 2 1/3 yards. Again, because it's a real world, we want to convert that to a mixed number. All right, looking at the next page of conversions, we have convert 10 meters to yards using a proportion. So again, let's set up our guide. Always set up a guide on the side, and I always label it. And I want to compare meters to yards. So meters to yards. Now, if you go on your conversion table that I gave you in class, you will see that 1 meter is 1.09 yards. That's the conversion which goes on the left. That is set equal to the other number that I'm given, 10 meters. So where's that 10 go? Look at your guide, it goes on top. What I don't know, again, is the yards, so we'll call that y. Convert 1y, or just y, equals 10 times 1.09, which is great because it's easy to multiply decimals by 10, or powers of 10. I just moved the decimal point. So it's 10.9 yards. These are not difficult as long as you follow that procedure that I'm showing you. Convert 450,000 millimeters to meters. So my guide in this case is millimeters on top, meters on bottom. So we look up the conversion, and you will see that there are 1,000 millimeters to 1 meter. I am given millimeters, so that goes on top. I'm going to leave out my comma because it'll be less confusing without it. And I'm looking for meters. So 1 times 450,000 equals 1,000 m. Divide both sides by 1,000, which is easy to do because I can just divide by all those zeros, and I get the meters is 450. So m equals 450 meters. On the last page, you will see some practice on your own problems. Please make sure you do those. Anything from an on your own we can go over in class, but it's eligible for a quiz or a test.